So now the C program structure is very simple. You have sort of these preprocessor directives, which I briefly mentioned in the last video, which are these includes, defines, and these are used for this sort of preprocessing of your text files, and they're very much used for code generation, human readability, sort of making it really easy to change variables on multiple locations. So you have these all over your program. You know, you could write an entire program without using this, but it's generally they're there to help simplify just writing good code, quick code, what have you. Now, there's functions like any programming language, really, and so these functions are blocks or logical blocks of code, which we'll get into in a minute, and variables. I mean, this is sort of standard coding, computer science 101, right? Like if a program is made up of variables that save something, and you do functions to do operations on data, variables, or what have you, maybe some peripheral. And so then you have the logic, which is implemented in these statements and expressions. And so these statements are like how you're using if statements, switch statements, loops, arithmetic operators, all of these sort of just coding, or for instance language dependent operators. C has them, but pretty much every computer programming language has these. These are what you use to implement the logic of your program, to tell it, hey, this is my data, I want to do this, and then you perform some sort of reactive reaction to the data that you have, the input that you have, what have it, right? And then also the comments. And those now for people that are getting into computer science, really I have to push how important it is to write comments in your code. And now this is because, like, even for myself, I've been writing code for a while and I write a lot of it in my day-to-day life. But I can look at code I wrote a month ago and I'll have any idea what I wrote because I'm doing so many things in between. And so really, if you document your code, I can help myself, like my future self, but most importantly, you can help other people understand your code. If you're working in a professional environment as a programmer, your code is probably going to go through lots of people's hands and they're going to have to be able to understand what's happening in your code. They probably don't want to all sit down and deconstruct your code line by line. And so if you can comment it, it can be much easier to read. Now, good coding style leads to code that sort of self-comments or self-documents. This is a topic for another lecture, but just write codes. I tried to annotate the code snippets in this lecture because you'll see it helps new people that don't quite understand the C language that well, to understand what's happening. It gives the like, not exactly the what, but the why, right? So this is what you want to explain. So now this is a basic program. This is Hello World. Like any programming language, is always a Hello World example. And so if we look, for instance, we have this preprocessor directives, the defines and the includes. And now what we're using in the Hello World example is we have this first include up here. Let's go to red. And so this is a preprocessor directive, this guy here. And so what we're doing here, which I'll explain later on when I sort of go across headers and includes, is I am just including library functions from the standard IO library. And so as you can imagine, standard IO, input, output, this is meaning it's giving me functions that let me do input and output things. In this case, it's giving me access to printf, which is going to print some string to this, like your standard out. And if you're on a Linux system, this is just your terminal, right? So if you run this program in a terminal, it's going to output the string to your terminal. Other systems, no idea, never use them. So the next thing that we come across, we have functions. And so just as I was saying, this include has included the standard IO library functions in its header file. And so the function itself is printf. And so this is the function we're going to call, or I should have gone through these slides. And so we have the printf function, which is doing this printing of a string, but most importantly, every C program is going to have a main function. Now the main function is the entry point of the system, of the program, and this is what's called by the operating system. So the operating system actually invokes the program sort of by calling it as a function. And so if the main function doesn't exist, the program or the operating system doesn't actually know where to go into the program. Now this is a bit different when we're dealing with embedded systems, but this all comes down to structuring it in memory and linking maps and whatnot. But in general, it's still just main, right? So every program must have one. Can't have more than one, but we'll go into this a bit more detail. I'm sort of doing a quick overview of an example program, and then we'll break each section down a bit more and really into detail in the next 5 hours. So now here we can see we have our comments. For instance, I have a block comment here. These are generally what you would use to comment functions. So if I wanted to actually write my own functions, let's imagine that I didn't have a main function, but I had some other function called, print hello world. I would write a little block comment there where I generally sort of explain what the function does, the parameters it takes, the output it gives, this sort of thing. So this is what a block comment's for, when you really need to explain a large chunk of explanation of some thing like a function, a data type, just basic logic for sort of more complex things. And then you also have an inline comment. So this is what you'll probably see most common, or pretty much only, in my lecture slides. And this is sort of where I'm trying to explain what's happening on this line. So I'm just, if I was to comment this, I would say printing out to the standard, printing hello world to the standard out terminal, right? To explain or to show how hello world works, right? Yes. So now, I think I explained this. The last thing that a function, or that you'll see a lot in code, is these return values. And so now we'll go into these when we talk about functions in depth. And a return value is essentially, it belongs to a function, and it's a value that is returned. So in a program returns a number. And so 0 is known as success. So if a program returns 0, my operating system knows, yep, it exited without an error. That's good, we're happy. But if the program returns a non-zero value, then the operating system takes it as an error code. The operating system doesn't do anything really with it because it doesn't know what to do with it, but you can, as a user, get the return value from the program and know if something's bad has happened, right? So now I'll go into C syntax.